Imagine this. You've built a time machine. Eager to test it, you punch in a date and pull the lever. The world around you dissolves into a blur. When it solidifies, you find yourself face to face with yourself, moments before you stepped into the time machine. What would you do? Would you stop yourself? Could you? This intriguing scenario, though fictional, forces us to confront a fundamental question: what is time, and can we truly manipulate it? For centuries, we've perceived time as a linear progression, an unstoppable march from the past, through the present, to the future. But what if time is not a rigid construct? What if it's more like a dimension, a landscape we could potentially navigate? Welcome to Tech Tonic, where science doesn't just explain the world, it shakes it up. We readily accept the three dimensions of space length, width, and height. We can move freely in these dimensions, back and forth, left and right, up and down. But time, we think, is different. It flows in one direction, carrying us inexorably forward. However, what if time is simply another dimension, interwoven with the fabric of space? What if, like the dimensions of space, time also possesses hidden depths and unexplored paths? This is the mind-bending concept that physicists have been grappling with for decades. To understand this, imagine a vast cosmic fabric. This fabric represents space-time, a unified entity where space and time are inextricably linked. Massive objects like planets and stars create curves and depressions in this fabric, much like bowling balls placed on a trampoline. These curves, as we will see, hold the key to understanding the nature of time. Our understanding of time underwent a revolution in the early 20th century with Albert Einstein's theory of relativity. Einstein shattered the Newtonian notion of absolute time, demonstrating that time is not a universal constant. Instead, it is relative, its passage dependent on factors like speed and gravity. Imagine two identical clocks, one stationary on Earth, and the other traveling at incredibly high speeds in a spaceship. According to Einstein, time would pass slightly slower for the clock aboard the spaceship compared to the clock on Earth. This phenomenon, known as time dilation, arises from the interplay between motion and the speed of light, which is constant throughout the universe. Einstein's theory of relativity unveiled the dynamic nature of time. It painted a picture of a universe where time is not rigid but fluid, warping and stretching under the influence of gravity and motion. Section 4. The curious case of time dilation. Time dilation, though seemingly counterintuitive, has been experimentally verified. Atomic clocks, accurate to within a fraction of a second over millennia, have shown that time does indeed pass slightly slower at higher altitudes, where Earth's gravitational pull is weaker compared to sea level. This phenomenon has profound implications for our understanding of time travel. If we could travel at speeds approaching the speed of light or venture near incredibly massive objects like black holes where gravity is immense, we could theoretically experience significant time dilation. Time, for us, would slow down relative to observers on Earth. While we currently lack the technology to achieve such speeds or withstand the gravitational forces near black holes, the concept of time dilation opens up tantalizing possibilities for traveling to the future. Section 5. Wormholes, shortcuts through space and time. Wormholes, hypothetical tunnels that connect two distant points in space-time, offer another potential avenue for time travel. These theoretical shortcuts, predicted by Einstein's equations, could theoretically allow us to traverse vast cosmic distances in shorter periods, effectively bending the fabric of space-time to our will. Imagine space-time as a folded sheet of paper. A wormhole would be like a hole punched through the paper, connecting two points that are otherwise far apart. By traversing this wormhole, we could potentially bypass the immense distances between stars and galaxies, effectively taking a shortcut through space-time. However, wormholes remain highly speculative. Their existence has never been definitively proven, and the conditions required to create and stabilize them are still largely theoretical. Nonetheless, the concept of wormholes continues to captivate our imaginations, offering a tantalizing glimpse into the mind-boggling possibilities of space-time manipulation. Don't forget to subscribe to our channel for more fascinating content on the mysteries of the universe.